Whatever I've achieved, I owe entirely to the Vedantu team. It's not just the in-depth subject matters that were taught to us, but also the exam-specific strategies we were asked to use.
हेलो गाइज, क्या हाल चाल है? हेलो अमनदीप, हेलो अजय, हेलो शाहिद, हाउ आर यू गाइज? कैसा चल रहा सब कुछ? So this is Saurav here and welcome to another series, another episode on Electrochemistry. We on the Vedantu channel on YouTube, we are conducting these classes and this is the 9th lecture on I'm fine. Hello Gabbar, hello IIT JEE Advanced aspirant, I'm fine, thank you, thanks a lot. So this is the 9th lecture in electrochemistry and until now we have done electrochemical cells, जहाँ पर कि हमने discuss किया था galvanic cells, and in the last session we had discussed about what is electrolysis. We had started with electrolysis. So we are on the process of identifying what are the different products of electrolysis, and we had did a small discussion in the last session, okay, on identifying the products. We'll start from there and today we would be taking all the very cases जो कि हम इलेक्ट्रोलिसिस के लिए यूज करते हैं. जितने केसेस हम यूज करते हैं इलेक्ट्रोलिसिस में जहां पर कि प्रोडक्ट्स आइडेंटिफाई करने के लिए जेई जिसके ऊपर क्वेश्चन पूछता है और एनी एग्जामिनेशन व्हिचएवर आस्क्स दीज क्वेश्चंस, वी विल डिस्कस ऑल दोज वेरी केसेस. ओके, सो हेलो अनित. So before we start, another reminder for you guys that yesterday the VSAT examination was conducted. The other date for the VSAT examination is Sunday, which is the coming Sunday, 4th of August, and the examination is gonna be at 3 p.m. Please do register for the test. Please do tell your friends as well, and because you can win amazing prizes and a lot of scholarships are to be there to win. A lot of scholarships for our paid courses as well. So please do let everybody know that these are from class 6th to class 13. 13 मतलब droppers के लिए भी है. Okay? चलिए, बहुत अच्छी बात है कि आपका रैंक 661 आया. And please do like, share and subscribe the channel. The word reaches out to masses and काफ़ी अच्छा होता है जिनको they cannot afford to get quality education can always use our platform for getting there where everybody is. Okay, so please do like, share and subscribe. Please do tell your friends about the channel. And with that idea in mind, अभी हम लोगों ने कहा हम अभी electrolytic cells पे हैं. Okay, we are doing electrolytic cells and we are discussing the various electrolysis outcomes. Okay, so in the last class I had told you that the products of electrolysis can be identified by using 4 factors, or there are 4 factors. Hello Anamika. There are 4 factors which help us identify what products can be obtained. Okay, so ये 4 factors क्या क्या हैं? We had discussed this in the last class. First is electrode potential. I told you that for all electrolytic reactions we are supposed to take delta G as positive, क्योंकि ये एक नॉन स्पॉन्टेनियस प्रोसेस है, एंड सो डेल्टा G would be taken as positive. If delta G is taken as positive, then जितना छोटा होगा इसका वैल्यू उतना फेवरेबल होगा. ओके, as small as possible is the value of delta G positive, that would decide the favorability. जितना छोटा होगा उतना फेवरेबल होगा. So electrode potentials of various competing reactions. The second is overpotential. Why is overpotential used? Overpotential makes a reaction which is otherwise going a little slow acquire a rate at which it goes on a little appreciable rate, मतलब fast थोड़ा हो जाएगा. So overpotential is the extra potential that you need to add so that एक slow reaction fast reaction में convert हो जाए. Okay, so overpotential of gases with respect to the electrode, so it varies from electrode to electrode. I'll tell you कि कहाँ पे इसको use करना है, but do remember that whenever gases are liberated at an electrode, we will have to use the concept of overpotential. Okay. The third one is concentration of ions. How does concentration of ions affect? Concentration of ions, if it is very low, then the cell potential will be very less, and so the process will not be quite favorable. Okay, so concentration of ions to be oxidized or reduced. And the last one is nature of electrode. Nature of electrode would also decide what products are formed. So there are four outcomes, there are four factors on which the outcome depends. Electrode potential, over potential, concentration, nature. Okay? Last class we had discussed electrolysis of molten salt, which is very easy to identify. Electrolysis of molten salt involves, मान लो कि मैंने एक सोडियम क्लोराइड ले लिया liquid state में, and I perform the electrolysis of it. Then what will happen? What will happen? Absolutely no competition from any other ion. There is absolutely no competition from any other. शिव हाँ पढ़ा चुके हैं, एक रिवीजन कर लेते हैं ताकि नेक्स्ट जो चीज़ आए उसमें ऐसा ना लगे कि कुछ भी नहीं आता है. Okay, so there is no competition from any other ion. So what will happen? Sodium will undergo reduction to change into Na, and this reaction will happen at which electrode? This reaction will happen at the cathode, because cathode is where reduction takes place, and at anode Cl minus will give out an electron and change into chlorine gas. Okay, this reaction will take place at the anode. If there is competition, then we will worry about electrode potentials, but since there is no competition, there is only one type of substance present, one cation, one anion, absolutely easy to identify what will happen. The same goes with H2O का अगर अपने electrolysis किया तो यही simple scenario आ जाएगा, but हम उसको अभी देख लेंगे. Okay? Next हमने देखा था ये वाला case, we had discussed this case, that electrolysis of mixed molten salt. Electrolysis of mixed molten salt. Suppose there are two different cations which are present. If there are two different cations which are present, then what I have to look for is these cations would be these cations like Na plus or an Al3 plus. Suppose there is Na plus and Al3 plus both are present. For reduction of Na plus to Na and reduction of Al3 plus to Al, I will check the delta G value. I will check the delta G value. So this value is Na plus to Na. This is given as Na to Na plus. This is minus 2.71 volts, and this one is minus 1.66 volts. So for this, delta G will be less positive, because I know that delta G is equal to minus NFE. So this, for this, delta G would be less positive, और इसके लिए delta G क्या होगा? Delta G would be more positive. So I would look for that delta G value which is less positive. So जो less positive होगा वो ज़्यादा spontaneous होगा. Usually delta G negative is spontaneous, but since we are getting positive values, तो हम less positive value को लेंगे. Okay, we will take less positive value. So what will which reaction will take place? This reaction will occur. Aluminium will get reduced, Al3 plus will get reduced to Al. Similarly, over here F minus is trying to undergo oxidation to F2, Cl minus is trying to undergo oxidation to Cl2. I will take the negative values of both of them. I will take the negative values of both of them because this is written for reduction. So if I take the negative value for oxidation, this is minus 1.36 volts and minus 2.87 volts. I will get a less positive value for this one. So हमने करना क्या है? Oxidation reaction के लिए जो potential है उसके लिए delta G निकालेंगे. For reduction reaction, I will calculate the delta G. Whichsoever gives me a less positive in oxidation, I will choose that reaction. Whichsoever gives me a less positive value in reduction, I will choose that value. Hello Saurav. Okay, so this is what we had discussed until इन द लास्ट क्लास. चलो इससे आगे बढ़ते हैं. ठीक है, इसके आगे हम देखेंगे वी विल टेक द केस ऑफ इलेक्ट्रोलिसिस ऑफ वाटर. दिस इज अ वेरी कॉमन रिएक्शन, वेरी कॉमन रिएक्शन. Water is a non-electrolyte. Water spontaneously is not dissociated into H plus and OH minus ion. Hello Sayam. So it's not dissociated spontaneously into H plus and OH minus ion. So to increase the conductivity of the liquid, increase the conductivity of water, I will add a salt, non-reactive salt like NaNO3, which will have no effect whatsoever. Okay, I will add a salt like NaNO3, जिसका कोई effect नहीं होगा. अब हम देखते हैं कि what would be the reaction. What would be the reaction? If I am electrolyzing water, I have a reaction where water would be undergoing oxidation and a reaction where water will be undergoing reduction. Remember this. Okay, so I will have this scenario. I will have a scenario where water will undergo oxidation. Also I will have a scenario where water will try to undergo reduction. ठीक है, ये दो चीजें हैं. Okay, water will try to undergo oxidation and water will try to undergo reduction. Now हम करेंगे क्या? अगर water oxidation करना है then water will give out electrons. लेकिन ऑक्सीडेशन होगा किसका? यहां पे O2 माइनस प्रेजेंट है, तो ऑक्सीजन का ऑक्सीडेशन होता है एंड इट विल कन्वर्ट इनटू O2. ठीक है, ऑक्सीजन विल कन्वर्ट इनटू O2. हम इसको 2H2O लिख देते हैं एंड दिस विल फॉर्म 4H प्लस एंड आई विल ऑब्टेन 4 इलेक्ट्रॉन्स. ठीक है, understood? H2O, if is being oxidized, it will change into oxygen. This O2 minus will change into O2 and what will be given out is 4 electrons along with 4H plus. ये reaction आपको याद रहना चाहिए. See, generally हम ये बोल देते हैं कि oxide ion will undergo oxidation, but H2O is not a strong electrolyte. Okay, H2O is not a strong electrolyte. अगर वो strong electrolyte रहता तो H plus and O ऑक्सीजन में spontaneously टूटा हुआ रहता, but it is not a strong electrolyte. If it is not a strong electrolyte, so that means I will not dissociate this while writing the reaction. Clear? I will not dissociate this while writing the reaction. इसको dissociate नहीं करेंगे. हम क्या करेंगे? I will take H2O on the reactant side and convert it into O2, take out 4H plus and balance it by giving out 4 electrons. ठीक है, now अगर मुझे रिडक्शन करना है, then हम करेंगे क्या? H plus को मैं रिड्यूस कर सकता हूं because हाइड्रोजन हैज अ पॉजिटिव चार्ज. H plus को मैं रिड्यूस कर सकता हूं because हाइड्रोजन हैज अ पॉजिटिव चार्ज. Now what I'll do is I will reduce it to hydrogen. Okay, it will take up 2 electrons. It will take up 2 electrons and what I will write over here is 2OH minus. और इस रिएक्शन को हम बैलेंस कर देते हैं. I will put 2 over here. Okay, try and understand. देखो, H2O has to be reduced. Within water किसको हम reduce कर सकते हैं? H plus को reduce कर सकते हैं because उसका oxidation state positive है. I can give electrons to H plus. So if H plus is to be reduced, it will reduce to hydrogen. Now if it is being reduced, ये 2 electron लेगा. What is the oxidation state? 2H plus 1. So it takes up 2 electrons, converts into H2, gives out 2 OH minus ions. Okay, so do remember these two reactions. ये दोनों reaction आपको याद रहना चाहिए because further in mains as well as in advanced, this reaction will be utilized in solving a lot of questions. First reaction में O2 को oxidize नहीं कर सकते. अरे O2 को थोड़ी oxidize करते हो, O2 minus को oxidize करते हो. This O2 माइनस को ऑक्सीडाइज कर रहे हो आप, ओके, O2 को ऑक्सीडाइज नहीं करते हो, ओके. What will happen? Oxygen will be liberated upon oxidation. So इसको मैं बहुत अच्छे से लिख देता हूं यहां पे, ओके. So hydrogen is reduced at the cathode. You can see H2O takes up 2 electrons, converts into hydrogen gas and gives out 2 OH minus ions. And the E naught for this reaction is minus 0.83. Okay, you can see the E naught for this reaction is minus 0.83. Clear? But E naught is this. अगर मैं E cell calculate करूं and I calculate E cell at pH 5, the E cell comes as to be minus 0.42. Clear? It comes as to be minus because E cell is dependent on the pH of the solution, because OH minus you can see is a product. So E cell will be minus 0.42. If I do the oxidation of water at anode, you can see the same reaction will happen, and you can check the E naught value is plus 1.23. Okay, the E naught value is plus 1.23. The E cell value however is 0.82 volts. ठीक है, E cell value is 0.82 volts. E naught और E cell के बीच में अगर आपको डिफरेंस समझना है, please do watch the lecture on Nernst equation. Okay, now let's try and understand कि हम what is the meaning of overpotential, because I had explained this to you earlier कि ये जो reaction आपको दिख रहा है, you can see this reaction, hydrogen's conversion into oxygen. This reaction though is favorable but is very very slow. Okay, and after ionization pH will change. Yes, it can change. Okay, however जितना यहाँ पे reaction हो रहा है वो equivalent amount में होता है, so pH remains the same. But if you perform the reaction in 2 different chambers, वहाँ pH change कर सकता है. This H2O, this reaction is favorable but it is slow. इस स्लो रिएक्शन को फास्ट बनाने के लिए हम एक्स्ट्रा पोटेंशियल ऐड करते हैं, एंड दिस पोटेंशियल इज नोन एज ओवर पोटेंशियल. दिस पोटेंशियल वैल्यू is somewhere between 0.4 to 0.6 for most of the electrodes. तो हम ओवर पोटेंशियल मान के चलते हैं कि ये 0.6 वोल्ट्स हम ले लेते हैं. सो आई विल कंसिडर ओवर पोटेंशियल as 0.6 volts. Remember, I will always consider over potential as 0.6 volts. ठीक है, इसके आगे कोई भी एग्जाम्पल आएगा वहां पे हम ओवर पोटेंशियल 0.6 वोल्ट्स लेके काम करेंगे. ठीक है, ओवर पोटेंशियल इज द एक्स्ट्रा पोटेंशियल दैट आई नीड टू ऐड टू मेक द प्रोसेस फेवरेबल. ठीक है, over potential is the extra potential which I need to add so as to make a slow process go fast. जैसे रस्टिंग एक slow process है लेकिन वो favorable है. एक बार रस्टिंग स्टार्ट होता है तो रस्टिंग बंद नहीं होता है. बट अगर उस slow process को मुझे fast बनाना है तो मैं कुछ और potential ऐड करूंगा, and that is known as over potential. So this over potential value is 0.6. Now how does over potential add up? किस तरह से over potential को ऐड करते हैं? तो आप ये देख रहे हो कि E is given as 0.4 minus 0.42. Can you see this? E is given as minus 0.42. Okay? E is given as minus 0.42. So what is the adjusted potential that I need to use? That will be E adjusted will be minus 0.4 to minus 0.6. Is it constant for every reaction? It is constant for a particular gas at an electrode. Okay. So E adjusted हम क्या कर रहे हैं, जितना भी ओवर पोटेंशियल होगा उसको हम ऐड कर देंगे. जितना E सेल का वैल्यू है, E सेल तो नर्स्ट इक्वेशन से आता है. रिएक्शन को फास्ट बनाने के लिए whatever is the extra value I will add it to, I'll add to it. So minus 0.4 to minus 0.6, this will become minus 1.02. Okay, I'll make it minus 1.02, and for this one E adjusted will be equal to plus 0.82 plus 0.6. I will not change the sign of, I will use the sign of 0.6 depending on whether the E cell is negative or positive. अगर negative है तो उसको negative रख के add कर देंगे. If it is positive then positive रख के add कर देंगे. It will always be added. Remember, this is always added. This is always added. इसको हमको हमेशा add करना है. Clear? So if I always add this, I will get 1.42 plus 1.42. Clear? I will always add this. So this is the adjusted potential that I need for the reaction to become favorable. This is the adjusted potential that I need for the reaction to become favorable. Is that clear? I hope this is understood. कि हमें तो अगर मैंने 1.42 volts यूज किया देन ये रिएक्शन भी हो जाएगा और ये रिएक्शन भी हो जाएगा. ठीक है? सो दिस इज द मीनिंग ऑफ ओवर पोटेंशियल. हाउ वुड आई यूज ओवर पोटेंशियल इन द नेक्स्ट केस? चलो देखते हैं. आई होप दिस इज अंडरस्टूड. नेक्स्ट केस और इंटरेस्टिंग हो जाएगा. लेट्स लुक एट द इलेक्ट्रोलिसिस ऑफ एक्वस NaCl. इज इट फॉर हाइड्रोजन इलेक्ट्रोड और प्लैटिनम? इट्स फॉर प्लैटिनम. ओके, इट्स फॉर प्लैटिनम इलेक्ट्रोड. Hydrogen electrode नहीं, liberation of a gas at a particular electrode. Next, let's look at this reaction. Electrolysis of aqueous NaCl with platinum electrode. Clear? Electrolysis of aqueous NaCl with platinum. Let's पहले हम identify कर लेते हैं कि cell ये oxidation reduction potentials use करके what reaction is more favorable. So let's look at the first thing. This one. Okay, let's look at this one. This reaction will take place at cathode and this reaction can take place at anode. Competition है? Is there a competition? Yes. Na plus and H2O के oxidation में competition है. Sorry, Na plus and H2O के reduction में competition है and Cl minus and H2O के oxidation में competition है. Okay, so there is a competition between Na plus's reduction and H2O reduction. There is a competition between chlorine reduction, chloride reduction and H2O chloride oxidation and H2O oxidation. ठीक है? So अगर हम सारे reactions को लिखें, I will write it as Na. So at cathode I will write it as Na plus will take up an electron, will change to Na. Clear? Na plus will take up an electron, will change to Na, and H2O will take up 2 electron, will change to H2 and give out 2 OH minus. For this E naught value is given as कितना दिया गया है? -2.71. Okay, and for this E naught value is given as -0.83 volts. ठीक है? You can see that the values are given as -0.21 and -0.83 volts. Now अगर मैं इन दोनों के लिए डेल्टा G लिखूं, if I am taking at cathode, if I take delta G for both these processes, then this is less positive and this will be more positive. Okay, less positive for this one, more positive for this one. Is this, are you able to understand? Please tell me yes or no in the chat box. Cathode पे जो reaction होगा उसमें Na plus will change into Na and H2O will change into hydrogen, and we can see that the E naught values are this. Okay, E naught values are this. For these E naught values, the delta G, if is calculated, I will get more positive value over here और यहाँ पे less positive आएगा. Okay, I will get a more positive value over here and a less positive value over here. If I get a less positive value over here, which is more favorable, which is considered to be more favorable, less positive value of delta G or more positive value of delta G? बताइए, less positive value of delta G or more positive value of delta G? Which is considered to be more favorable? Less positive. So which reaction will take place at the cathode? Which reaction will take place at the cathode? This will take place at the cathode, this will not take place at the cathode. So cathode पे कौन सा, what will be liberated? What will be liberated at cathode? अगर मैं इसका products लिखने की कोशिश करूं, then cathode will have liberation of hydrogen gas. Cathode will have liberation of hydrogen gas. ठीक है? Cathode will have liberation of hydrogen gas. Now let's try to identify anode पे क्या होगा? At anode. Okay, at anode, H2O is converting into O2, 4H plus, 4 electron. E naught value is given as, कितना दिया गया है? 1.23 volts. This is given as minus 1.23 volts. ये minus दिया गया है. Okay, and Cl minus converted into Cl2 will give out an electron. This E naught value is equal to, अब देख लीजिए, it's given as minus 1.36. It is given as minus 1.36. Now for both these reactions, if I write delta G, if I write the expression for delta G, then I will get less positive value of delta G over here and more positive over here, isn't it? I will get less positive for the first reaction and more positive for the second reaction. Yes? So what we will say is that anode पे क्या liberate करना चाहिए? What will be liberated at the anode? What will be liberated at the anode? Oxygen. Okay, general idea ये है, लोग ये बोल देंगे कि oxygen liberate कर जाएगा, but that is a mistake. Okay, that is a mistake. Don't ever say that oxygen will be liberated, क्योंकि आप अभी just हमने पढ़ा, what did we discuss right now is something known as overpotential. Overpotential will always be present. So यहाँ पे overpotential का अगर हम add कर देते हैं, if I add overpotential, so overpotential हम add करेंगे, यहाँ पे कितना add करेंगे? minus 0.6 volts. Okay, if I add overpotential over here, this will become minus 1.83 volts. Is that understood? Over potential is the extra potential that I need to add. तो over potential जब add कर देंगे, then this will become minus 1.83. And यहाँ पे over potential अगर मैंने add किया minus 0.6 volts, then this will turn into minus 1.43 volts. So minus 1.43 is still less than minus 2.71, तो ये रिएक्शन आराम से हो जाएगा. बट जैसे ही हम यहाँ पे ओवर पोटेंशियल ऐड करते हैं, द मोमेंट आई ऐड ओवर पोटेंशियल ओवर हेयर, दिस बिकम्स minus 1.83 एंड दिस वैल्यू नाउ बिकम्स लेसर. कैन यू सी दिस? क्लोरीन में ऐड नहीं करेंगे यार, क्लोरीन का ओवर पोटेंशियल बहुत कम होता है. ओके, क्लोरीन ओवर पोटेंशियल इज वेरी वेरी लेस. ऑक्सीजन एंड हाइड्रोजन में हम ओवर पोटेंशियल हमेशा ऐड करते रहेंगे. So the moment I add over potential for oxygen, the value will become minus 1.83 and this will still be minus 1.36. So right now, what will be less and what will be more? This will become more and this will become less positive. So at anode, chlorine gas will be liberated. Okay, at anode chlorine gas will be liberated. So wherever you see oxygen get competing, liberation of oxygen coming into picture, जहां भी ऑक्सीजन के लिबरेशन का क्वेश्चन आ गया, ऑलवेज ऐड ओवर पोटेंशियल, ऑलवेज ऐड ओवर पोटेंशियल. क्लियर? सो वेरी इंटरेस्टिंग केस, हाइड्रोजन एंड क्लोरीन इज लिबरेटेड. ठीक है, हाइड्रोजन एंड क्लोरीन इज लिबरेटेड. और ये बहुत इंपॉर्टेंट है क्योंकि दिस इज अ वेरी इंपॉर्टेंट मेथड फॉर एक्सट्रैक्टिंग क्लोरीन फ्रॉम सी वाटर. एक्वस NaCl कहां पे रहता है? सी वाटर. ओके, ओशन में जो वाटर है उसमें सोडियम क्लोराइड डिसॉल्व रहता है. सो फ्रॉम दैट ऑब्टेनिंग क्लोरीन and hydrogen in large scale is utilizing this concept. Okay, is utilizing this concept. Clear? ठीक है, चलिए. So let's take the next question. अब आपको समझ में आ गया है. So let's work on these questions. Electrolysis of aqueous CuSO4. जल्दी जल्दी बताइए क्या होना चाहिए. Electrolysis of aqueous CuSO4. You can see that Cu2 plus changing into Cu is 0.3 plus 0.34. This is minus 0.83. This reaction, these two reactions are competing for cathode, and these two reactions are competing for anode. Okay, these two reactions will compete for cathode, these two reactions will compete for anode. प्लस 0.34 दिख रहा है, ये माइनस 0.83. प्लस 0.34 आई एम ऑब्जर्विंग ओवर हेयर, माइनस 0.83. सो फॉर दिस डेल्टा G विल बी नेगेटिव. डेल्टा G विल बी नेगेटिव, इजंट इट? ये फर्स्ट वाले के लिए डेल्टा G नेगेटिव हो जाएगा, इसके लिए डेल्टा G पॉजिटिव रहेगा. सो विच वुड बी मोर फेवरेबल? Which would be more favorable? Delta G negative is more favorable or delta G positive is more favorable? Negative. ठीक है, delta G negative will be more favorable, and so electrolysis of aqueous copper sulfate, our cathode will have liberation of, or you can say deposition of copper. अरे रिडक्शन हो रहा है, देन वाई नेगेटिव? अरे देखो यहाँ पे वैल्यू क्या दिया गया है, Cu2 प्लस चेंजेस टू Cu इज प्लस 0.34 दिया गया है. ओके, ट्राई नॉट टू मिस आउट ऑन दिस थिंग्स. Cu2 प्लस चेंजेस टू Cu इज गिवन एज प्लस 0.34. अगर ये प्लस 0.34 दिया गया है तो ये मतलब रिडक्शन हो रहा है. Cu2 प्लस चेंजिंग इनटू Cu इज गिवन एज रिडक्शन. रिडक्शन के लिए डेल्टा G नेगेटिव हो गया, रिडक्शन के लिए यहाँ पे डेल्टा G पॉजिटिव है. ओके, now this is given as minus 2.01, this is given as minus 1.23. okay, minus 1.23. what I am supposed to do, I have to add over potential of 0.6. I have to add over potential of 0.6. this will become minus 1.83. okay, and this will still remain as minus 2.01 volts. Now which is lesser, which, or for this delta G will be positive, for this delta G will be positive, delta G will be less positive, delta G will be more positive. Which reaction will take place? Which reaction will take place? The one for which delta G is less positive, the one for which delta G is less positive. So at anode I will get oxygen. ठीक है, at anode I will get oxygen. ये क्वेश्चंस को आप 2-3 बार सॉल्व करोगे, आपको पता चल जाएगी कहाँ पे क्या रिलेट होना चाहिए. एक दो वैल्यूज तो आपको याद ही होने चाहिए. H2O converting into water converting into hydrogen, that is minus 0.83 volts, and H2O getting converted into O2. Okay, H2O getting converted into O2 is minus 1.23 volts. Clear? So always evaluate, always put over potential into picture and then try to solve the question. Okay? Next question, electrolysis of, अरे इस पर based question, अरे नेगेटिव पॉजिटिव समझ नहीं आ रहा यार, डेल्टा जी पॉजिटिव होता है, डेल्टा जी एंड इलेक्ट्रोड पोटेंशियल क्या रिलेशन है? What is the relation between delta G and electrode potential? Delta G is minus NFE. Delta G is minus NFE. If delta G is minus NFE, then delta G negative is favorable. Delta G positive is less favorable. अगर मैं if I get two values which are positive, if I get two values which are positive, let's say I get two values which are positive, let's say +2 आ गया +4 आ गया, okay, if I get two values which are positive for delta G, then which is more favorable? The one which is less positive is more favorable. Less positive is more favorable. ये लास्ट क्लास में डिस्कस किया गया था, ओके, दिस वाज डिस्कस्ड इन द लास्ट क्लास. प्लीज डू वॉच, ओके. अगर आप रिवीजन नहीं करोगे तो यू विल ऑलवेज फेस इश्यूज. इलेक्ट्रोकेमिस्ट्री इज द मोस्ट चैलेंजिंग टॉपिक इन ऑल ऑफ फिजिकल केमिस्ट्री. प्लीज डोंट इग्नोर इट, ओके, प्लीज डोंट इग्नोर इट यार. एंड फॉर नेगेटिव, ट्राई एंड आइडेंटिफाई. ईजी है. नेगेटिव में क्या होगा? आई गेट टू वैल्यूज -2 and -4. More negative is more favorable. More negative is more favorable. ये तो this we discussed in electrochemical cell as well, as in like galvanic cells में जब Nernst equation वाले questions कर रहे थे, then we took this concept. Please do watch those videos, okay? So having said that, electrolysis of aqueous Na2SO4, okay, electrolysis of aqueous Na2SO4. तो Na2SO4 का अगर मैं इलेक्ट्रोलिसिस करने की कोशिश करूं, देन aqueous मतलब वहां पे वाटर भी प्रेजेंट है, ओके, देयर इज वाटर ऑल्सो प्रेजेंट ओवर देयर. इफ वाटर इज प्रेजेंट, देन देयर आर टू कंपीटिंग रिएक्शंस फॉर कैथोड. ये कैथोड पे कंपीटिंग रिएक्शंस हैं. -2.71 volts, -0.83 volts, for which I will be getting a less positive value of delta G. For which I will be getting a less positive value of delta G. बताइए. For which I will be getting a less positive value of delta G. अरे less positive. अनित, हाउ कैन इट बी सोडियम? अरे यार, हाइड्रोजन ऑक्सीजन कुछ भी लिखे जा रहे हो. थिंक केयरफुली. दिस इज गिविंग अस डेल्टा जी विच इज लेस पॉजिटिव. दिस विल गिव मी अ मोर पॉजिटिव वैल्यू ऑफ डेल्टा जी. Okay, this will give me a more positive value of delta G. So less positive value of delta G is obtained for this one. ये इसको लेके less positive. Less negative दिख रहा है तो वो less positive होगा. Okay, you can see that less negative, so it will be less positive. So less positive value will be more favored. Okay, so at cathode what will be liberated? At cathode what will be liberated? बताइए. एट कैथोड व्हाट विल बी लिबरेटेड? हाइड्रोजन गैस, बिकॉज दिस रिएक्शन विल बी फेवरेबल. वाटर का रिडक्शन इज मोर फेवरेबल टू लिबरेट हाइड्रोजन गैस. ओके. एट एनोड you can see that when you take this SO4 minus oxidizes to give S2OA2 minus. Okay, SO4 minus gives S2OA2 minus. Okay, this is known as per sulfate ion. Okay, per sulfate ion. This इसका जो conjugate acid होता है, that means H2, oh sorry, if I not conjugate acid, if I take the acid from where this can be derived, it will be H2S2O8. okay, yeah Ganesh, you have to, okay, if they don't mention, they will not mention, they will not ask you, you have to do that. So H2S2O8 से ये anion derive होता है, and H2S2O8 is known as per disulfuric acid. This is known as per disulfuric acid. Okay, so let's look at these two values. What I have to do, I have to add overpotential. Overpotential कितना ऐड करेंगे? 0.6, which will give me the value as minus 1.83. I will take this final adjusted value and this value and compare both of them. Which is less negative? This is less negative, and so this will give delta G, which will be less positive. This will give more positive delta G. Okay, so what will be oxidized? What will be oxidized? Water will be oxidized. Water will be oxidized. ठीक है, ऑक्सीडाइज किसका होगा? वाटर का ऑक्सीडेशन हो जाएगा. एंड इफ वाटर इज ऑक्सीडाइज्ड एट एनोड, आई विल गेट वाटर. सो आई विल राइट ओवर हियर, कैथोड पे क्या मिल रहा है? सॉरी, एट एनोड, एट कैथोड आई विल गेट H2, एट एनोड I will get O2. ठीक है, doesn't it look like कि मैंने वाटर का इलेक्ट्रोलिसिस कर दिया है rather than Na2SO4, क्योंकि Na तो मिल नहीं रहा है, also सल्फेट का ऑक्सीडेशन हम देख नहीं रहे होते हुए. So doesn't it look like I am performing electrolysis? Doesn't it look similar to electrolysis of water? Yes. So remember, this is a very important concept, that if you take the if you perform the electrolysis of Na2SO4, K2SO4, Li2SO4, CaSO4, magnesium sulfate, it is actually equivalent to the electrolysis of water. Okay, it is actually equivalent to electrolysis of water. Clear? Very simple concept. However, इसके लिए मुझे कुछ डिस्कशन करना पड़ा है पहले. अगर कहीं भी आपको समझने में दिक्कत आई, प्लीज डू re-watch the previous video and this video from the beginning. Okay, चलो next case लेते हैं. Electrolysis of aqueous NaCl and which is very dilute. Electrolysis of aqueous NaCl which is very dilute. ठीक है, very dilute. अगर मैंने सोडियम क्लोराइड बहुत dilute ले लिया, then what will happen? And this is where concentration of ions का आ जाता है. What we have considered until now, electrode potential consider कर लिया, over potential consider कर लिया, but we haven't considered concentration of ion. So this is an example of concentration of ions. So if I take very dilute solution of NaCl, इसका मतलब concentration of Na plus is very low, and concentration of Cl minus is also very low. Concentration of Cl minus is also very low बोलेंगे. So what will happen कि इन दोनों का concentration इतना कम रहता है कि इन दोनों का electrolysis होने की possibility बहुत कम हो जाती है. Okay, and what gets electrolyzed is this and this. What was happening in aqueous NaCl which was not quite dilute? हाइड्रोजन वॉज लिबरेटेड, फाइन, बट यहां पे हम ओवर पोटेंशियल लगा के क्लोरीन को लिबरेट कर रहे थे. वी वेर लिबरेटिंग क्लोरीन एक्वस NaCl में, बट जब मैं लेता हूं वेरी डाइल्यूट, देन इसका कंसेंट्रेशन बहुत कम हो जाता है, एंड सो इट इज लेस अवेलेबल फॉर इन सब्सटैंशियल अमाउंट, एंड सो ओवर पोटेंशियल इतना बड़ा फैक्टर नहीं रह जाता है. कंसेंट्रेशन बिकम्स अ इंपॉर्टेंट फैक्टर. ओके, Earlier what I was doing is I was using the concept of overpotential when the concentration of chloride was substantial. Okay, if chloride concentration is good, then I will use the concept of overpotential. But the moment it is very dilute, I will not use the concept of overpotential. I can just say that this entity is very very less, तो इसका ऑक्सीडेशन होना फेवर्ड रहेगा. ओके, इसको और एक तरीके से एक्सप्लेन किया जा सकता है. इफ आई राइट द ई सेल, सो क्लोरीन इफ इज अंडरगोइंग ऑक्सीडेशन, आई विल राइट इट एज दिस. मैं इस तरह से लिखूंगा, आई विल राइट इट लाइक दिस. सो लेट्स से वी राइट द ई सेल फॉर दिस, आई विल राइट इट एज ई नॉट Cl minus changing into Cl2 minus 0.0591 by n log of chlorine gas, pressure of chlorine gas to the power 1/2 by the concentration of Cl minus. ठीक है, ये इक्वेशन आएगा अगर मैं इसके लिए ई सेल निकालने की कोशिश करूं. दिस इज नस्ट इक्वेशन. नाउ ट्राई एंड अंडरस्टैंड. इफ दिस इज वेरी लो, if this is very low, don't you think that this value will be very high? This negative value, whole negative, ये denominator में है, so this negative value will be very high and E cell will be highly negative. E cell will be highly negative. देख लो, if this value is very low, this whole value will be very high and this E cell will be highly negative. तो मैं ये बहुत, it is a highly negative value and this is still adjusted value is minus 1.83 and this could be even more than 3 volts 4 volts के ऊपर चला जा सकता है. So which would now be favored if I use the concept of potentials? Less positive value मुझे लेना है, so this will give me less positive delta G and highly negative means highly positive delta G. ठीक है, इतने डिटेल में भाई कोई नहीं बताएगा आपको, इसीलिए अच्छे से समझ लीजिए इसको. If I take a very low concentration, ion availability is less, so oxygen is liberated. This is like the most common explanation. The other explanation comes from Nernst equation, that E cell Cl minus is very less, so this value will be very large and E cell will be highly negative, delta G will be highly positive. Highly positive value तो यूज नहीं करते हैं हम, less positive value यूज करेंगे. So इसमें हमें क्या मिलेगा कैथोड पे? At cathode I will get hydrogen, at anode I will get oxygen. Clear? ठीक है, चलिए नेक्स्ट वाला ले लेते हैं. ओके, एक लास्ट केस लेते हैं, उसके बाद कुछ जो और केसेस बच जाएंगे उसको अगली बार ले लेंगे. ठीक है, सो ट्राई एंड अंडरस्टैंड. यहां पे क्या होगा? इलेक्ट्रोलाइसिस ऑफ एक्वस NaCl यूजिंग मरकरी इलेक्ट्रोड. देखो अभी यहां मैंने इलेक्ट्रोड चेंज कर दिया. ओके, आई हैव चेंज द इलेक्ट्रोड, मरकरी ले लिया मैंने. Now what Mercury does is it will form an amalgam with sodium. Sodium's Na plus reaction to Na is not very favorable. Okay, it is not very favorable. So if it is not favorable and somehow this is being removed from the reaction medium, then the equilibrium will shift in the forward direction. अरे gold electrode नहीं लेते हैं यार. Okay, Tia, nothing will appear interesting if you do not want to put your heart into it. Okay, so try and understand कि topic when it is difficult you have to put efforts. Okay, Na plus if it is converted to Na, this reaction is less favorable. It is less favorable. What Mercury will do is Mercury will take this sodium and will pull the equilibrium in the forward direction. Okay, mercury will pull the equilibrium in the forward direction, and so this reaction will take place. Similarly, mercury will combine with this to form a complex Hg2Cl2, and so this equilibrium will less favorable reaction shifts in the forward direction. So यहाँ पे हमें मिलता क्या है? Sodium and chlorine. Okay. So when I take an electrode, the electrode can participate in the reaction and can pull the equilibrium in the forward direction. Okay. So this is this is the second leg of Faraday's law. Okay. This is second leg of Faraday's law. I have two items A and B. The potential of A is more than B, but N value is less than B, which is, so whenever we are taking, potential is always delta G by N. So electrons does not play any role. Okay. Electrons do not play any role. So remember this, guys, that we will be discussing two more cases in the next class, and in the next class we will also talk about the laws of electrolysis which help us identify how much of the substance, यहाँ तो हमने देख लिया कि ये liberate होगा, but how much substance will be liberated will be calculated using Faraday's law. Okay, so please do join us in the next session, and this is Saurav Goswami taking leave, and I hope you have learned a lot. Please do practice this because ये आप बहुत जल्दी भूल जा सकते हो. Okay, तो एक बार rewatch कीजिए, फिर से practice कीजिए. Okay, चलिए guys, bye bye and have a lovely time.